Hey guys, this is part 2 video for chapter 1, section 1. You can see where we left off here. Some of these problems are already done. If you are trying to find f of a number like number 7, it's as simple as plugging that number in for x in the original problem. So number 11 is going to be a little trickier. But again, let's establish this. Hey, if I see an f here, which stands for function, it tells me which function to use. I want to use the f function. In the f function, if you look up here at the top, it says 3x minus 7. So in other words, it's 3 times something minus 7. So it's just a matter of putting that something into the parentheses. And if you think about it, right here, you already have a set of parentheses. So just got to pop that, write it just like it was in the problem. So the n plus 5 went in place of the x, and then we just do whatever math is humanly possible. So we'll distribute a property to get the 3n. We'll distribute a property to get 15, and just keep going until there's nothing else you can do. Well, I can't put the 3n together with the 15, but I can put the 15 and the minus 7 together. Positive 15 and negative 7 makes positive 8. So I can't add 3n plus 8, and I'm done. Now, it'd be tempting, because there's an equal sign, you're thinking about, hey, I got to solve an equation, get n by itself, but there's nothing over here. And if there's nothing over there, it's called simplifying, or it's an expression to do. So an expression means get as far as you can go, and you're done. So 3n plus 8 is as far as I can go. So number 12 is getting ahead of ourselves a little bit. Let's see if you remember some of these rules for exponents. Again, the G tells me which problem I'm using. So I'm using this problem over here on the right. And all I'm doing is plugging something into the problem where the x's were. So I like doing it this way. You don't have to. I think it makes it pretty darn obvious. So whatever's in the parentheses in the problem is what goes in the parentheses when you work it out. So my 4a cubed goes here. Again, calculator's not going to help me because I don't know what a is. So, well, what comes first in PEMDAS? Do we do multiply first or do we exponents first? So I can't do the 2 times the 4 first. I got to do this little squared feature. Now, I would hope that you guys would know a 4 is getting squared, so it's going to be 16. And the rule for the exponents, should you forget, in that situation is 2 times them. So I get an a to the 6th. So common mistake is to go a to the 5th there. Haven't done the 2 yet. Now this guy, minus something, what if I put a 1 there? If I distributed it, would anything happen? The answer is no. So there's really no need for the parentheses there. All right, well, one more thing to do. Go do all the math you can do. So I got a 2 times a 16. I can do that. So I've got something with an a to the 6th minus something with an a to the 3rd plus a 5 that has no a at all. Are those like terms? Can I combine them? And the answer is no. So the answer to that guy is what we're looking at. 32a to the 6 minus 4a cubed plus 5. Again, it's not an equation. I don't have anything over here. I can't move stuff from side to side and try to solve it. So that's it. That's all we're trying to do is simplify these. All right. Down here are some graphs. So the question is, are these graphs of functions or not? So I'm going to skip to this middle one in the top row just to show you real quick why. This guy right here is going to be no, it's not a function. So I'm going to put these 2 dots, color them in. We know there's an infinite number of dots. So I'm going to make up some grid marks. And so the guy on the bottom here would be negative 3, comma something. I don't even care what the something is. I'll tell you why in a second. Wouldn't the guy at the top, since he is lined up vertically, also be negative 3, comma something? And we learned in part 1 video, to be a function, you have to have all different x's. In other words, you can't have a repeat in the domain. The x's can't repeat. Well, that top dot is negative 3, comma something. The bottom dot's negative 3, comma something, and that's a no-no. So the easier way to go about it is just to do this. If I make a vertical line down through the drawing, I've hit the drawing twice, which means I have 2 x's that line up, and I have multiple x coordinates that are the same, which is why that guy's a no. So over here in this first graph, anywhere that I make a vertical line in that drawing, I'm only hitting one individual dot, one individual dot, one individual dot. So there's no coordinates above or below to line up. Therefore, there's no multiple x's. Therefore, yes, this guy is a function. So over here, I can make a vertical line right there on that third graph, and I'm not only am I hitting it twice, I'm hitting it 3 times, which means there'd be 3 repeats or 3 multiple x's. So that's a no. So again, this is called the vertical line test. Pretty simple concept. If you can draw a line anywhere vertically and hit it more than 1 time, it's a no. But this one I can only hit 1 time. Now this one's a little tricky. If I draw right here, I only hit it 1 time. But what happens if I draw it right there? So it's anywhere in the drawing. If you can hit more than 1 spot vertically, it's going to make it a no. So even though this last graph is pretty crazy looking, I hit it once. I hit it once. Once, 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 once. There's no way I can hit that vertically more than 1 time. And that makes that guy yes. He's a function. So the graphing portion is pretty easy, just a matter of remembering it. So it's called the vertical line test. So I'm not going to give you a definition for that because you just saw it demonstrated. So vertical line test means there will be multiple x's. So the last thing in section 1 is something called discrete continuous, and it's just another way to subdivide or subname a function. So discrete is as simple as this. If you have a bunch of coordinates, a list of coordinates, for example, so you had 4, 6, you had -1, 0, you had -3, -2. I don't have any repeats in the domain, therefore it's a function. But these would just be 3 dots in the middle of nowhere. Now, where does it say we have to connect them? So discrete means it's just a finite number of coordinates. So there's no arrows on the end of a graph going on forever. So discrete coordinates, simple as that. Continuous means it goes on forever. If it goes on forever, it's got to be an equation. Something like this. Y equals 2x plus 7. If you did take the time to graph that guy, you'd be a linear straight line. And what do the arrows on the end mean? It continuously goes on forever, or continues. So that is basically it. That's a subdivision for 2 different names for functions, 2 different kinds. So the coordinate one up here is still a function because we don't have any repeats in the domain. We got a 4, a -1, and a -3. They're all different, but they're not connected. They're just 3 points in the middle of nowhere. So that makes those discrete, and continuous is an equation. An equation has an infinite number of coordinates, and this guy does pass the vertical line test, right? If I make a vertical line, it only hits it 1 time. So it's still a function, but it's continuous. All right, guys, that brings us to the end of the notes for Chapter 1, Section 2. Thanks for watching.